Alright folks, today we're going to work on problem 2 of our limiting reactants worksheet. Okay, this is only problem 2. Okay, one of the nice things about this one is it's asking you for how many liters of carbon dioxide are formed. That just means we're not going to have to do as much math calculating masses. Alright, we are going to have to calculate the mass of methyl alcohol. So if we look at methyl alcohol, let me just put that up here at the top, since we're going to be doing that. CH3OH, if we go and do the math for that, we will find out that methyl alcohol weighs 32.042 grams per mole. Alright, so let's go and create our balanced chemical equation. We have oxygen gas. Remember that oxygen is diatomic. It's a Brinkelhoff element. And we're adding it to methyl alcohol, also known as methanol. And when we do that, we produce carbon dioxide and water, because this is clearly a combustion reaction. Hopefully you figured that out. It's burning. And when you actually balance it, you're going to have to put a 2 there, and a 2 there, and a 4 here, and a 3 over here. Because you have 2 carbons, and you have 8 hydrogens, you need the 4. And then when you do the oxygens, because you do them last because they're all over the place, that should come up with. Okay? Alright, now what do we have? We have 20 liters of oxygen. And over here we have 20 grams. And these all have 3 sig figs. So just kind of remember that as you're going through it. 20 grams of methyl alcohol. And our question is, how many liters of carbon dioxide? How many liters of carbon dioxide do we come up with? Right. So let's go ahead and do this problem. We're going to start with oxygen first. And we start with 20.0 liters. And we have to convert from liters of O2 to moles of O2. And then from moles of O2, we have to go to our target, which in our case is moles of CO2, because that's what we were asked in the problem. And then we go from moles of CO2 to liters of CO2. Alright, so what are our units? Well, 1 mole of O2 is 22.4 liters. And our moles of O2, we have 3 moles of O2 going to 2 moles of carbon dioxide. So we have a 3 to 2 relationship. And 1 mole of CO2 is 22.4 liters. Now, if you're real good with math, you'll notice that 22.4's cancel, but you don't have to do that. You can plug the whole thing in. And when you plug the whole thing in, you get a total of 13.3 liters of CO2 that's produced. So let's try methyl alcohol, CH3OH, and we start with 20.0 grams. Right? Notice we're not with liters here, we're with grams. The reason for that is methyl alcohol is a liquid at room temperature. And we are going to convert from grams of CH3OH to moles of CH3OH. That was pretty messy, wasn't it? And we're going to go from moles of CH3OH to moles of carbon dioxide, and again we want to switch from moles of carbon dioxide to liters of carbon dioxide. Alright, so what do we know? Well, clearly liters is 22.4 liters in 1 mole, we know that, and our ratio of methyl alcohol to carbon dioxide is 2 to 2, so we can just put 2 to 2 in there, and we've already calculated the molar mass of methyl alcohol, which is 32.042 grams in 1 mole. So we do that math, and we come up with 14.0 liters of carbon dioxide. So they're pretty close, but clearly oxygen's our limiting reactant. So oxygen's limiting, and we have 0.7 liters that were not able to be produced, because 14 minus 13.3 is 0.7. So 0.7 liters of CO2 we have to convert back to the thing we had in excess, because we want to figure out how much we had left over that we did not use. So we go from liters of CO2 to moles of CO2, and then we go from moles of CO2 to moles of methyl alcohol, and then we go from moles of CH3OH we go to grams of CH3OH. So let's see, 22.4 liters in 1 mole, and our relationship between carbon dioxide and methyl alcohol is 2 to 2, and 1 mole of methyl alcohol has a mass of 32.042 grams. Right, when we do this math, we will come out with 1, and that's all you can have is 1 sig fig, 1 gram of methyl alcohol. So that's how much you had in excess. So we're done. That's it. Questions? See us in class. Have a good one. Bye-bye.